Welcome to Maths Bridge. Let's learn Java programming. Folks, please do visit us at our YouTube channel Maths Bridge. I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. To demonstrate how Java decompiler works, today I'm going to show you like the detailed steps, but in quick note, this was the sample source code that I created. And then if you can having like all the white spaces, comment lines, and it's nothing but like a non-executable statements, and there are some executable statements, right? When you compile this, you would see that a class file corresponding to your source code. Class file is nothing but a bytecode which is JVM understand, right? JVM is the one who actually takes this class file, load it in the system, and run it on the actual hardware. Okay, anyway, so you export this in a complete project as a jar file. It includes the class files. That jar file is what you're gonna import into your Java decompiler to see back the source code. If you can import, and then this is what you see, the source code. Do you see the difference between these two? There is no comment lines here, except everything is optimized code is what you see, which is what you needed. In the reverse engineering, if you have a class file, you can extract the source of the class file, but it appears to be like something like this. You missed seeing them white spaces and then also comment lines, but the logic and then code still remains in the source. That's what beautiful, right? So let's see stepwise process how you gonna set up the decompiler and dependencies, and then create a project and import the project into Java decompiler, and then see this through. As you know, we see Java C compiler. Using Java C compiler, we generate a Java source code into class file, right? Now we are trying to do like reverse engineering. Let's assume that you have a class file, but you wanted to see source code from that class file. Is it possible? Yes, it is possible, because Java C is a compiler. Similarly, we have a JD like in Java decompiler, which basically aim it to actually extract the source code from the class file. Java decompiler is a tool. We have a the 4 different versions which are available under GPL v6 license. As per the development point of view, I think you feel free to use whatever it is. Commercially, there is the few constraints that you have to go through. JD GUI and JD Eclipse plugin, JD Core, are the main Java decompiler projects which we can use as a tool to extract class file. Extract the source code from the class file. So you could go and actually look at java-decompiler.github.io, where you can actually see that all options. We have releases like a .jar file and JD GUI 1.6.6 main.jar. At the time of this video recording, these are the the versions that are available. You might actually see that latest version, depends upon your timeline. We have a RPM, we have a tar files, we have the zip file. I would prefer to use like in a zip, which I can download and then extract and then just play with it. Here is the URL for downloading a JRE corresponding to Java JD compiler, what it requires. Java.com /en/download, where we can see 16-bit Java for Windows, which is what I needed for my system. But you can get whatever based out of a platform, you can download the required jar file onto your system in order JD the application to run. JD means like a Java decompiler. Here you go. Once the file gets downloaded, upon your download link, what I can see is like the file gets downloaded into your download folder of your system, right, in your PC or laptop. So this is what the the file that I get downloaded, JDGUI Windows 1.6.6 zip file. I extracted that file into same folder, right. I unzip the basically the folder. So now I can see this is what my source code. I could see like a JD-GUI graphical user interface exe file and associated. So I can run this file. If I run this, it has its own limitation, but because this particular application is being built on Java runtime environment 1.8, and hence I would actually try install that precisely for this JD decompiler to run. What I would do, right, I already downloaded JRE 8 version. Let me actually install this now. Okay, so I'm installing. That's good. So what I will do, like this gives me like a kind of like a warning stating that like this is like a non-commercial version. So for you as a developer, probably you can use it, but you can't commercialize if at all you are trying to do something on this. Okay, so make sure I think you follow the policies in place. Okay, so now what I will do, like I will try install it. So it takes a few the minutes, not much. It is a quick one. Almost I'm done. All right. Okay, seems it is successful. You have successfully installed the Java. That's good. So that means now we can close it. Try launch my application. Okay, so it is launching. To demonstrate how Java decompiler works, what we can do, like we can create a Java sample project using your Eclipse IDE. So here is my package name, and then here is my file. The file, if you look at the source file java main.java, where I have like the few executable statements and then few comments. Comments are non-executable statements, right? We know that. So one section that I created for creating variables called as declaring the variables. The other part actually I'm initializing the variables and computing in here, right? Calculation part. In this case, like what I'm doing is like I will take two input numbers and summing them, and then the result will be storing in the variable called sum, which is what I am actually printing on the console using system.out.println. If I would actually let this program runs, I'm sure I think it's already compiled. If runs, what you get is like the output. The output would be sum of given two numbers is 300. So 100 and 200, 300. That's good. This is what I think we know. So let's see like next step. If I'm going to navigate in your source directory in file system, this is what the place where I created my source file under the package day 15 and -1. This is like a package name under which I have a source file. So since I compiled this code, so what you would expecting, the corresponding class file, where would that would be? So if you look at a hierarchy at high level, Java learning level, you have the bin directory. Within a bin you can have a com, MethodSprich, day 14-1. This is where I think I have a class file. This class file is kind of like a this is basically what we can call it as like a platform independent bytecode, which is being generated out of your source file by Java C compiler. Java C is like a Java compiler, right? Now we are trying to look at this class file and then see how Java decompiler regenerates a source code, basically extracting a source code out of this class file using JD, Java decompiler. Now what we have to do, we will assuming that like we are going to export this file as a jar file, like an archive file, by using like an export option under file menu, right? What I do, you can see that go to file and go to export, right? So when you get the export, you will see this jar file is what I wanted to create out of my the file structure, which I will do. So click on next, it will generate. So if I would recap what we did actually, we downloaded the Java decompiler on your system, and then it has a dependency of JRE, and then we installed that as well. So now this application is going to be launched without having an issue, which we demonstrated, right? So if we double click this one, this is how I think it came up as a menu. That is fine. So now what you have to do is like how you are going to use this to import your file and then see source code, right? What we did that we compiled as a sample program, and then we also see that how class file getting generated, and then in the file system where you can see them, right? What we did that we export that complete project as a jar file, and then which we copied into some directory in our file system, right? Now we know the source file where it get downloaded. So what we do, like we drag and drop that file into your what we can call it as this Java decompiler, the application. Here is what I have, jd underscore test.jar is a file that is given while I was exporting from IDE. What I would do is like I will drag this into this. You see how I did it? Here you go. So now we have complete source path you can see on the Java decompiler. So if you look at this, this is what the structure that we created, right? com _hyphen. So do you remember, this is what the the project that we created? This is the source file, and then upon my export, the jar file which I downloaded back, imported back to JD compiler by drag and drop. Now I could see this is what the Java decompiler seeing my jar file. So if you look at this package, right, I can explore this. This is the Java main.class file, right, which is corresponding to your Java main.java file. So now you can double click this. This is what the source code which I get it. Do you see now the difference between these two? Right, I have the package name, I have the class name, I have the main, and then all the white spaces, you see this is like structured properly to see it, and then all white spaces and the new line, what you can call it as the comments, all gone, because those are called as a non-executable statements. Class file doesn't have them, right? Compiler won't take it while it compiles the code. So compiling process takes care of only considering the executables. That's why I could see like int num declared and initialized, but it showing me as a declaration, and then assignment done at a single state. Both are equal, right? Variable declaration and initialization put together is one state. That's what a decompiler recognizing. You also see 17, we have a declared as a sum, but we computing them here, put them together as equal as int sum, and then you have s printf. Do you see now? At least merely like entire source code is now you could see from class file to source mapping by using like a Java decompiler. This is one of the best method for actually if you have a Java code in terms of a class files or jar file, but trying to see what the source code look like, and then Java decompiler is as a capability, has a feature to extract complete source code from class files, right? This is very beautiful and very important utility which we may need it during your reverse engineering of the code, sometimes like to extract the source out of your class files. But there are the cases where you have a complete jar executable jar file, but you don't have like a source code for it. But this is one of the way that you can extract the source code out of your class files. Thanks for watching. Please like, share, subscribe, click on bell icon, and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.